Hello, Algebra kids. It's time to review for the Chapter 6 test. So, when you begin watching this, you should have the extra credit completed, possibly even corrected. I do throw in extra things here and there because I kind of look at to make sure I'm not missing anything while I'm doing it. So you may want to just listen to the whole test or quiz or extra credit, even though you may not have had questions on anything. So here we go. And I have this cord in the way, which is bothering me profusely. Let's slide this down. Okay, so which ordered pair is a solution? So they give you two linear equations, and you have to figure out if a pair is a solution. So if it's a solution, it works for both of them. So you need to make sure you substitute this in and see if it works for both of them. If it doesn't, then you try the next one. So let's go ahead and do that. So this is our x and this is our y. So I'm going to go ahead and substitute that in there. So I have, let's see here, negative 1 equals 2 times negative 1 plus 1. Remember your order of operations when you're doing this, because oftentimes sometimes kids will add instead of multiplying first. So remember, you multiply first. So 2 times the negative 1 is negative 2, plus 1 is negative 1. Check. That works. All right, let's try the next one. Y equals x. Well, that's straight up. Y equals x. Yeah, they're equal. Check. There was nothing to even do with that one. So the answer is A. So when you look, like sometimes it'll be something like, let's just flip this and say it was x equals 1 plus 2y. Let's just say it was written that way. Well, sometimes people will go in and go like this. Oops, sorry. X is negative 1 plus, oh my gosh, what is wrong with me? Let's try that again. Negative 1 equals 1 plus 2 times negative 1. And sometimes when it's written that way, they want to go 1 plus 2 is 3. And 3 times negative 1 is negative 3. No, you have to make sure to remember multiplication comes first, and then you add the 1 back in. Okay, onward. Graphing. So on this test, you are specifically going to be told how to solve some of these. So you have to use the method they say, and I will be checking the work to make sure you use the right method. So as you know, there's 3 methods. There's graphing, and there's substitution, and there's elimination. So make sure you read carefully. Graphing, we just got to plot those. First step in any graphing problem is to make sure they're written in the proper form, which is y equals mx plus b. The reason we want the y alone is because then you can pull out the y-intercept, and you can pull out the slope. All right, so when we are going to, one moment please, I hear some music I don't really care for in the background. Okay, so I'm back. Apparently I'm the only one in the house who understands words in songs. So we will just write that one off and move along here. We have our 2 equations. So the y-intercept is always graphed first, so I'm going to do the first line in pink. So when I look at this, the intercept is a negative 3. So I'm going to go down negative 3, right there. And then I'm going to do the slope, which is before the x. Remember, if there's nothing there, that means there is a 1 there. So I'm going to rise 1, run 1. I'm going to grab a straight edge. Yes, where's my straight edge? Need a straight edge. Especially when you're graphing, because you want the best possible estimated answer, and if you're not using a straight edge, it's kind of turned into a wild guess instead of a pretty good estimate. Okay, repeat. Y-intercept is 5. And slope is a negative 1 in this case. So remember that you can put the negative with the top, the bottom. It doesn't matter, but I always just do the top. So I'm going to rise down 1, which sounds weird, and run a positive 1. Grab my straight edge. so now we're going to see where is that point that they intersect. And so mine falls right there. So I'm going to guess that my lines were just off a hinge. It's probably meant to be right there. So before 1. And that is the answer. Make sure you put your X first and then your Y. And I will look at your graph. So if it is a hinge off, or if right here you said 3 3/4 and 1 1/4, something like that, I obviously would give you credit for that. All right, now next we're going to go into substitution. Okay, that is where originally I said, okay, you need a y alone. Do you have one of the equations where y is alone? And the answer is most definitely yes, right there. Y is all by itself on that side. Then you say, what is it equal to? It's equal to 10 plus x. So I need to substitute that 10 plus x in place of that y and rewrite it. So I'm going to do 2x, that's still there. The plus is still there. I'm now going to put my y in. 10 plus x. Whatever is over here gets put in there. And then finish up the rest, equals 4. So now we just draw our line and solve our equation. Just make sure you combine like terms first, because I have a 3x and a 1x there, which you can get, I'm sorry, a 2x and a 1x, which is a 3x. Plus 10 equals 4. Subtract 10 on both sides. 3x equals a negative 6. Divide by 3. And x is a negative 2. Done? No, because we're looking for a solution. Remember, these are the solutions, a coordinate where they cross. So I have the first part of it, but until I have this whole thing, and sometimes it's helpful, like even down here, to just put, I'm sorry, I don't want that in there yet, to put the parentheses so you don't forget that there are two things. I'm sorry. I am definitely type A. That just bothers me. Okay. So let's go back up here. We got our negative 2 for x, so now we need our y. So go back here. Y is what? Is 10 plus x. So y is equal to 10 plus our x, which is negative 2. And that is 8. And we are all done. Sliding down to elimination, that is the one where you want to be able to take two equations with two unknowns and add down and have either the x's or the y's cancel off. Sometimes you have to manipulate them. Sometimes they don't work perfectly, but in this case, what you see is they do. Which ones fall apart or disappear when you add down? Yep, the y's. So I'm going to draw a line. I'm going to add straight down, and I'm going to get a 1x plus a 4x, which is a 5x. Negative 2y plus positive 2y, that's the one that cancels out. I'm going to rewrite my equal sign. Be careful with your adding. Negative 7 plus 22, what is that? 15, very good. Now divide by 5, and x is 3. So I'm halfway there. Now you have to pick one of them, substitute it in, and get the y. So you can pick the top equation or the bottom. You just take it exactly the way it is. I'll take the top one. So I have x minus 2y equals negative 7. So I put the 3 in, minus 2y equals negative 7. So I'm going to add or subtract 3 on both sides. Don't forget this though, you have a negative in front of it. So it's a negative 2y equals a negative 10. Divide by negative 2, and y equals 5. You could have taken the second one. Maybe you don't like the subtraction and dealing with the negative, so you grab the second one. That's fine. So I'm just going to show you how that works out. So you have 4 times 3 plus 2y equals 22. So 12 plus 2y equals 22. So minus 12 on both sides. 2y equals 10. Divide by 2, and still x equals 5. So, or not x, I'm sorry, that's a y. Y equals 5. So that works out that way. Doesn't matter which one you pick. All right, so we're going to go up here now to graph. The graph, oh, hang on, I think it's time for a commercial break. Have I already done a commercial break with Zevia? It's the best. It doesn't have garbage in it. It has, let's just notice this here. Whoa, you need to get that clear. Ooh, what do you see? We never quite know what natural flavors means, do we? But stevia leaf extract, that's pretty good. And caffeine, I do like caffeine, but I don't drink Monster drinks, but I do not mind a little bit. So there you go. Crack it open. There we go. So feel free to get you guys some water, get something to keep your brain going. And now we shall begin the second column. Well, it says the graph of a system of linear equations is shown below. What's the solution? Well, let's just understand this is one line and this is one line. So your solution is where they intersect. Oops, no, it's blurry. That's no fun. So you just have to look and see, where do they intersect? Right here. What is that? It's 2, 2. Done. So hopefully that is not a problem for any of you. Understanding that where the two linear equations cross is your solution. Next, 6. What is true about the equations of a linear system if the system classified is inconsistent? Well, first of all, you're going to be able to use your sheet, which I don't have here with that chart on it. But my question to you would be, what kind of lines are inconsistent? Yes, parallel lines. Good. And the reason there are is because they don't have any solutions. And the only way they're not going to have any solutions or anywhere where they cross, like see how they cross here and they cross up here, is if they're parallel lines. And so what's true about parallel lines? Well, we know their slopes are the same, for sure. So slopes are the same, slopes are different, slopes are different, slopes are the same. So we got 2, so we can rule these out. Then we go on to the y-intercepts. And if they're parallel lines, let's just think about over here. If I drew a line parallel to this pink one, it's going to be somewhere like about right there. Or anywhere I could draw it in. But my point of this is that here's my y-intercepts. They're never the same. So it's going to be this. If the slopes are the same and the y-intercept, that's when you have a consistent and dependent situation where they're right on top of each other and they have infinitely many solutions because they overlap. Now the solution of which linear inequality is graphed below. So they give us a bunch of options, and you can again take a look at this to figure out the possibilities. You know, hang on, I'm going to go back to this last one. There was something else I wanted to add. If I said something had one solution, like this has one solution, how would you label that? Because we said that right here, inconsistent ones were parallel lines. Inconsistent means there's no solutions. So we've got 2 options left. For consistent ones, consistent means there is a solution. There's 2 possibilities. It's going to be either there's one or there's infinitely many. So what is it called when there's one? Is that the dependent or independent? That's right. If there's one solution, that means it's consistent because there's a solution, and it is independent. It's a totally separate line. Dependent means the same line. Okay, back to this. So we've got this. We're going to rule some things out. Number 1, we're going to look at this line. This line is a solid line. So when we know it's solid, that means it includes all the solutions on that line. So we want to find the ones with the equal under it. Here's one, and here's one. And that comes from this being a solid line. So these are now off the table as options. Next thing we want to look at is shading. If it's above the line, up here, that would be a greater than symbol. But it's not, it's below the line, so that is a less than symbol. So we want to look and find our less than, and that is going to be our answer. We could also look at the slope. The slope, if we look at it, rise 1, run -1. So it's a negative slope, which is what they have. And what's the y-intercept? 0. And that's what they have, +0 on all these. There's no +0. So only thing you had to go by was the inequality piece. So, and that's going to be the same way on the test. Okay, I'm going to give you an equation. It's not going to be this one. But the only thing different is going to be these signs so that you can figure, I want to make sure you know what they mean. The graph of the system of linear inequalities is shown below. Which order pair is a solution? Okay, so we've got two different things going on here, don't we? Wait, we only have 2 rows left. I have 2 more commercial breaks. Okay, the first commercial break is a recommendation I have for you, which is this wonderful book. We are entering Lent, and I would highly recommend this book. It is called The Young People's Book of Saints. It looks like Hugh Ross Williamson. Has a lot of great saints in here. When my son is being confirmed, I said, okay, read this book and tell me which one you can relate to. Yeah, you want to know who he picked? I'll tell you who he picked. He picked the oddest one in here. There it is, Saint Benedict Joseph Laborer. Right there. Yeah. He was a street person who lived with one book, which was what was the book? Oh, darn, I can't think of the book. He had one book he carried with him in the Bible, and then he just reached out to people, giving almost everything away. So, inspiring, yes. Hoping my son is reaching for more than being a street person, but we'll see. Anyway, so saints come in all shapes and sizes, and that's why we are called to holiness, no matter where we are in this life. Now, when we look at this, I'm going to shade and show you this part again, because do you see this dotted line right here? You can see the part that's shaded is above it, so I'm going to shade it. And then you can see that the other part is dotted, and that's below this line, so I'm going to shade that. And now it says, where's a solution? So remember, a solution is where they overlap. So in this case, it's all this orange. It would not, repeat, not be on this dotted line, but it could be on this solid line. So let's check them out. -3, -6, -3, -6. Nope, that's not. 0, -2. 0, -2. Yep. But I'm going to make sure that the other ones also don't work, so I didn't make a mistake. -2, 0. Yep, that doesn't work. And 3, -6. Yep. So these are in one of them, but they're not in both. Okay, nice work. Tell whether that's a solution. It's the same as the beginning of this when we said, are these solutions? Only here you had to punch it into both of them. Here you're just plugging it into one inequality. So this is my x, this is my y, and I get 10 is greater than 5 plus 6 times 1. Oh, here's one of those situations. Make sure you don't add the 5 and 6. Okay. Well, in this case, actually, it's not going to matter, but you multiply first. So 10 greater than 5 plus 6, 10 greater than 11. Is 10? Now you ask, is 10 greater than 11? No, it is not. Is it a solution? No, it's not. This has to be true. Okay, let's look at the bottom one here. It's kind of similar, only there's two. Tell whether negative 6, 0, again, x and y, is a solution. So let's try the first one. If I get a no, I'm done. So 0 is greater than negative 6 plus 4. So figure it out, 0 greater than negative 2. Is 0 greater than negative 2? Yes. Check. Try the next one. 0 less than negative 2 times negative 6. Negative 2 times negative 6 is a 12. Is 0 less than 12? Check. Yes, it is. So my answer to the whole problem is yes. All right, last column here. This is going kind of fast. And the solution of which linear inequality is graphed below. Okay, so you have to come up with the line. And this is the same way it is on the test. You have to go look at that line and the shading and figure out what that equation is. So if you remember, I said to start with the slope-intercept form of a line, just to remind yourself the things you have to figure out. And the things you have to figure out is less than, greater than, equal, not equal to. Slope, y-intercept. All from looking at this. Okay, so I'm going to start with the y. That's the same. Now I'm going to look and say, is it greater than or less than? Is it below or above the line? It is below the line. That is a less than. Over here, shading would have been greater than. Now I look and say, is there an equal? Do I put an equal under here? Okay, it's solid. Therefore, yes, I do include it. Now I got to do slope. So I got to find two coordinates where they intersect nicely. And I'm just going to look real quick at something. I think it's a little easier to read on the test than on here. This is kind of difficult to read. It goes by, what is that? 4? What is that? Oh, it goes by 2s. Okay, so this is 6. This is 18. And then it goes right through there at 12. So it rises 1, 2. I cannot read this for the life of me. This is painful. Rise 6. Okay, yeah, I'm going to look at my other example here to see if I can see what it is on here. Oh, it is more clear on here. I have a -4, but I'm not seeing the -4 here. Oh, I see it goes right through here. Okay, let's try it out. Let's go from there to there. 2, 4, 6, 8, 10, 12, 14, 16. So a rise of 16 over 2, 4. Okay, 16, okay, it does work. -4. So a rise of -16, and then go left -4, so it's a -4. But again, I'm just reassuring you that on the test, it's clear. And if it's not clear, of course, ask me, because I don't want you getting it wrong, because you can't read the graph, obviously. Last thing we have to do is get the y-intercept, and where does it hit? And it hits at -18, right here. All done. Last one. All right. So we have two graphs. Give two ordered pairs that are solutions and two that are not. Okay, so this is the big kahuna, really. This is the one that is worth like 4 points. So You want to make sure you understand this one clearly. So let's start with the first one and graphing it right here. Remember our equation, y equals mx plus b. So the first thing you want to do is graph your y-intercept, which is a -4. So I'm going to go down, put my dot on -4. Then we have to do the slope from that point, and the slope is a -1/2. So you can put the negative at the top or the bottom. I'm going to put it with the top. So I'm going to rise -1 and run 2. Another bad graph. Sorry about that. We'll do our best. Now before I connect those lines, I want to see if it's equal or not. And it is. It does have this line right there. So I know that it's solid line. So I'm going to connect them with a solid line. All right, right through the whole graph. Now we have to do shading. So it says greater than. So which side? Right, the top. So again, I would at least shade in most of the, if not all, right along the line, because it can get a little confusing when you get the second line on there. Okay, now I'm going to grab the pink. All right, look at the second one. What's the intercept? Intercept's at 1, so I put a dot there at 1. And then slope is a 1. So rise 1, run 1. So the slope is here. Before I connect them, I'm going to see if it's equal to, and it is. So I'm going to do a solid line. Now we are going to shade, and we have to look up here and it says less than. So I need to focus just on this line. This is where it gets a little tricky because people maybe start shading over here and they get the two lines. Keep it focused. And sometimes it helps when you just put your protractor or card or whatever it is you had there on the line, because it prevents you from shading where you're not supposed to. I highly recommend that actually, because I've seen this more than once and I just came up with that grand idea myself as we speak. Oh, gorgeous. All right. Now, can you get the answer? Well, let's see. Solutions are in here. That's my solutions, the orange. So pick two and pick obvious ones. Then you don't have to make a mistake with that. So I'm going to do 4, 1. And I'm going to do 6, 1. And you can pick any in here and they'll be right. I check them all. Non-solutions could be in the pink. It could be over here with nothing. It could be in the yellow. All of them are non-solutions. So I could pick -4, 1. I could pick -7, -2. I could pick -4, -7. Again, it doesn't matter which of these three. They're all no. All right. Wow. That's the end, and we're about to go celebrate the Super Bowl, and when you watch this, you're going to know the winner. But I highly recommend Lesser Evil popcorn. It is made with premium or quality, minimally processed with organic extra virgin coconut oil. But what I would actually recommend is homemade popcorn with coconut oil and sea salt. All right. Who are we going to vote for? I'm going to go for the 49ers. All right. Take care.